Hi kids, now we'll be going with this circular motion derivation in magnetism, which we already know, but I'll be just showing you mathematically. So the question is, if there is initial velocity of the particle, let me say positively charged particle, it is moving along x-axis with velocity u and magnetic field is into the plane, and the initial moment, the magnetic force will be v bar cross p bar, it will be in this direction. Probably like you people would have learnt, it will be performing circular motion. Now I will be proving more mathematically the same thing. Now I don't know what is going to happen in future, so assume like I don't know. So when I don't know, like I will be predicting after some time it can have some velocity along x-axis, velocity along y-axis, velocity along z-axis. So at any moment velocity will be having x component, y component, z component, and magnetic field is x component is 0, y component is 0, z component is minus b, so negative z-axis, right? Now force at any moment, force at this moment is going to be q into v bar cross b bar, q into v bar cross b bar. So I will be finding the force. So q into v bar cross b bar, when I find the force I will be getting this much. So if I know what is the force, I can find what is the acceleration by dividing with the mass. So when I divide with the mass, I will be getting acceleration is this in x axis, y axis and z axis. So acceleration along x axis is this much, acceleration along y axis is this much, acceleration along z axis is 0. So basically I am writing them separately here. Acceleration along x axis is this thing is coming again and again, so I am calling it as omega. So acceleration along x axis is minus omega into vy, acceleration along y axis is omega into vx, acceleration along z axis is 0. Now if acceleration along z axis is 0, velocity along z axis will be constant. Initially it was 0, so finally also it will be 0. So basically it is not moving along z axis, it is moving only along x axis and y axis. So this motion will be only in this plane, that we concluded. So we concluded the motion will be only in this plane. So now I am not bothered about z axis thing. Now I need to solve these equations. So what I am doing, we can solve it in many ways. Initially I am solving it this way. I am taking this thing, I am writing as it is, this minus, right? Yes, there is a minus here, minus omega vy. Now this is this thing. Okay, I think this minus is here, and okay, that was the problem. I think, yeah, I made it correct here. Okay, fine. So this one dx by dt I can write, this one dvx by dt, this one dy by dt, and if I integrate, or okay, I wrote this one as dvx by dt, so I brought this dt this side and I am integrating. Yeah, I mean you can do that. Yeah, you could have done some other thing. So you can write this as dy by dt, you can write this as dvx by dt, dt will go and you can integrate. So what is this? This is dy. So dy, when y coordinate was initially 0, initial velocity along x axis is u. When the y coordinate is some y, velocity along x axis vx. So from here I will be getting this equation. Now similarly when I do the integration here, when this is x coordinate, when x coordinate was 0, velocity along y axis was 0. When x coordinate is something, then velocity along y axis is vy. I will be getting this relation. Now this is dx by dt, this is dy by dt. I need to find equation of trajectory. I don't need time, and time is not coming at any other place, only is coming only here. So the better option I have seen is taking the ratio. When you take the ratio, you will be getting this equation. Now from here I will be bringing variable separable form and I will be integrating. When x coordinate is 0, y coordinate was also 0 because it was at origin initially. When x coordinate is x, y coordinate is y, we should find the relation. So when I integrate I will be getting this thing. I am modifying it, I am bringing everything this side, and I am modifying it so that I can get it like y minus something whole square format, right? Now if you see this one, it is u by omega, omega is qb by m, we assumed. So u by omega is basically mu by qb. Let me call it as r. If I call it as r and if I substitute, I will be getting x square plus y minus r whole square plus equals to r square. What does this mean? This is nothing but circle with center 0 comma r, circle with center 0 comma r. So basically this is the thing, circle of radius r with center 0 comma r, right? So it will be performing this circular motion. Now this is what we will be getting mathematically, and we will try to understand v bar cross b bar is in this direction. So because of that it will try to perform circular motion. When the velocity is this way, v bar cross b bar again force is towards the center, so it will keep on performing circular motion. This is what we will be understanding physically, right? We solved this one using some math, but we didn't, at least I didn't have a clear idea what we were doing. We were just manipulating things and we reached it. So we will be going in a more organized way of solving it. So what are those two equations we got? These two equations. These two equations we need to solve. So those two equations I am writing here again. Those two equations I am writing here again, and I need to solve these two equations. So what I will be doing is, I will be differentiating this equation again. Then x double dash is nothing but minus omega into y dash. So I will be substituting x double dash is minus omega into y dash, then I will be getting this equation. If you see this equation, this is y dash, this is y dash double dash. So it is vy and this is vy double dash. So that is SHM form. When something is of SHM form, then the general solution will be a sin omega t plus phi, or so that's the equation. I am bringing that equation. If that's the equation, then the general solution will be a sin omega t plus phi or p sin omega t plus q cos omega t. Now there are two unknowns here, so we need two conditions. So I will be differentiating this again. P sin omega t differentiation is p omega cos omega t. Q cos omega t differentiation is minus q omega sin omega t. At t equals to 0, velocity along y axis was 0. At t equals to 0, velocity along y axis was 0. When you substitute t equals to 0, sin omega t will be 0 and cos omega t will be 1. Now similarly, what is this acceleration along y axis initially? What is the acceleration along y axis initially? Acceleration along y axis initially is omega times of velocity along x axis initially, omega into u. Acceleration along y axis initially is omega into u, and cos omega t will be 1, sin omega t will be 0 at t equals to 0. From here you can see q is 0 and p is u. Once you know this, you can just substitute it back and you will be getting this one. P is u, q is 0. So u sin omega t. Velocity along y axis is u sin omega t. If I know velocity along y axis, then I can integrate it to get y coordinate, and constant will be coming. You know initial conditions. What is the initial condition? Y coordinate was 0 initially. So from there you will be getting the constant is u by omega. Now u by omega, if I call it as r, u by omega if I call it as r, then this equation will look like this. So y coordinate as a function of time I figured out, which is same as this thing. Okay, anyway here we didn't do, fine. Then I need to find x coordinate. So what I will be doing, I will be taking this equation, x double dash is minus omega into y dash. Now y we have already got, so y dash is going to be, you can substitute y dash from there. Then you got x double dash. When you integrate it, you will be getting x dash. Initial limits, initial velocity was u, so by initial limits you will understand this is going to be 0 by initial limits. Now again when you integrate with initial limits, then you will be getting x equals to r sin omega t. So what are the two things we got? X equals to r sin omega t, y equals to r into 1 minus cos omega t. Now you can eliminate sin and r, sin and cos by sin square plus cos square equals to 1. When you do that, you will be getting this equation, which is circle equation. The same equation what we got before. Earlier we didn't have some regular method of solving it, we just somehow managed to do it. In the second way, what we were doing, we were seeing some SHM form, but the problem was velocity term is looking like SHM form, so we had to go through many steps. Now that was happening because there is alternate plus and minus. So when there is alternate plus and minus, we can cut it short by the help of complex number. So we will be doing the same integration in a slightly different way. Again the same two equations, we solved these two equations in two different ways before. Now we are going to involve complex numbers, which will make things little easy. Now what I am going to do is I am going to multiply this equation with I, and I am going to add these two equations. When I add these two equations, I will be getting this thing. Now from here I will be taking I omega common, that is this thing common. If I take I omega common, I will be getting x dot, that is velocity along x axis thing, okay, whatever, you will be getting this thing. When you take I omega common, you will be getting this thing. Now there was a minus term, now minus term disappeared, because you know I square is nothing but minus 1. Now that's the good thing about using complex number, negative thing disappeared from this equation to this equation. Now if you see, okay, I am rewriting it, I am rewriting this equation. Now if you see this equation, I can write it as differentiation of this one, So I am writing this equation as differentiation of this one. Now suppose if this thing I am calling it as v, complex number. Yeah, I mean velocity along x axis plus I times of velocity along y axis, I am calling it as velocity thing, complex number. Then it is going to look like this equation. Now if this is the equation, then the general solution is going to be this format, or you can integrate also, that's up to you, but general solution is going to be this thing. Now I quickly know what is this constant. I mean, this will be some constant into e power I omega t, but I know what is that constant. What is that constant? What I assumed as v, this thing. Now what is v's initial value? Initial velocity along x-axis was u, initial velocity along y-axis was 0. So what is v's value initially? V's value is going to be real number and value is u. At t equals to 0, v's value is real number and value y is u. From there I will be getting this constant as u. At t equals to 0, v's value is real number and u. From there I will be getting this value is u. Now I will be expanding this. So v is nothing but velocity along x-axis plus I times of velocity along y-axis, that equals to u into this thing is cos theta plus I sin theta, cos omega t plus I sin omega t. Now I will be equating real quantities and imaginary quantities. So I will be getting velocity along x-axis is u cos theta, velocity along y-axis is u sin theta. Now when I integrate this with limits properly, I will be getting x coordinate is r sin omega t, where u by omega is r. Now similarly with the initial conditions, if I integrate, I will be getting this thing, which is same as what we got before, but it in much less steps. So when I integrate, I will be getting x value, y value, then when you do sin square plus cos square equals to 1, I will be ending up getting circle. Now out of all the 3 derivations, this derivation is going to be little slick way out of the others, right? Thank you.